In this video, we're going to be talking about density. Density doesn't really fit super well in this chapter, but it does involve some math and it does involve units. We're going to talk about it now. Here's a question you can ask your friends or small children if you want to make them feel dumb. What is heavier, a pound of lead or a pound of feathers? The answer obviously is they weigh the same. They both weigh a pound. People who say lead are normally thinking about equal volumes of the two. The relationship here between mass and volume is called density. If I had a pound of lead and a pound of feathers in these two boxes, the scale would balance out and they'd weigh the same. But it would be very difficult to put an equal amount of mass in these boxes, especially because feathers are very, not dense. So you would need a much larger container for, in reality, to equal out this scale. So the formula for density is mass divided by volume. This is on table T. You don't need to memorize it, but you probably have used this before in middle school science, and we're going to use it a lot. You'll probably memorize it, but you don't have to. It's on table T. The common units that we use for density in chemistry are grams per milliliter. This is a derived unit by taking mass measured in grams and dividing it by a unit of volume, like milliliter, and you get grams per milliliter. Sometimes it's in grams per cubic centimeter, and in gases it's always in grams per liter. So next I'm going to show you something called the magic triangle. You may or may not have learned this in other classes. So if you take a formula like density, a simple formula like density equals mass over volume, you can turn it into what's called the magic triangle. So you take a triangle and you divide it into three sections. You just put the formula into the triangle. So I'm going to put density there, mass on top, volume on the right. Let's replace those words with symbols. Density equal density, D for density, M for mass, and V for volume. So if two things are side by side in the magic triangle, you multiply. If two things are above and below in the magic triangle, you divide. So if you want to solve for, say, density, you just cover up density and you get your formula mass divided by volume we have here. If you want to solve for volume, you cover up volume on the triangle and you get mass divided by density. If you wanted to solve for mass, you cover up mass and you get density times volume. And that's how the magic triangle works. And you can use this for density, or you can use your algebra skills in this very easy formula, your choice. All right, so let's do a practice question. A copper penny has a mass of 3.1 grams and a volume of 0.35 centimeters cubed. What is the density of copper? So we could use our magic triangle, or we can just use this formula and plug in the variables that are given. So the mass is 3.1 grams, and we're going to divide that by the volume, which is 0.35 cubic centimeters. And then we just punch in our calculator, 3.1 divided by 0.35, and that equals 8.9 grams per cubic centimeter, or grams divided by centimeters cubed. How about this one? What is the volume of a pure silver coin that has a mass of 14 grams? The density of silver is 10.5 grams per cubic centimeter. Okay, so they want us to solve for volume. So if we cover up the V, we get mass equals, or mass divided by density for volume. So they gave us the mass, which is 14 grams, and they tell us the density, which is 10.5 grams per cubic centimeter. So you punch that into your calculator, 14 divided by 10.5, and you get 1.3 cubic centimeter. So the unit is cubic centimeter because you see you have grams above and grams below. These two units will cross off or cancel, and you'll get cubic centimeters. Of course, is a unit of volume in the metric system. Okay, another thing we need to talk about is density and sample size. So picture I have a glass of pure water. Water has a density of 1 gram per milliliter. If I have a sample of matter here, this little block that weighs 1.5 grams per milliliter, we should be able to predict what's going to happen if we put it into the water. Of course, it'll sink. It is denser than the water. It's 0.5 grams per milliliter more dense than the water, so it will sink. But what if I take it out and I take my block and I cut it in half? And I then put that piece into the water. Can you predict what's going to happen? Of course, it's going to sink. Because density is a intensive property of matter and it doesn't change. The density of half of this block is still 1.5 grams per milliliter. If I took a quarter of this block or one atom of this sample of matter, the density will not change. Density is a physical property and it does not depend upon the sample size. It depends on the type of matter present. Here's a chart. You can find this in most textbooks or something like it. It shows the density of some common materials, and you could use something like this to predict where something would sink in water or oil or something like that. Another chart that you have in your reference table, table S of course, has lots of values of all the elements, and one thing it has is density, measured in grams per cubic centimeter, and you could use this to help you answer questions on density. Another thing we need to talk about is density and temperature. So what happens to the density as the temperature of an object increases? Well, the mass remains the same. If I heat an object, it's still going to weigh the same. It's just going to be hotter. But most substances increase in volume as temperature increases. And this is the science behind hot air balloons. If I heat the air in this balloon with the little burner here, the air inside starts moving more and further away from each other, and it takes up a larger space, meaning it has more volume. So density generally decreases as the temperature increases. You're dividing by a bigger volume when you heat up something like air. So your answer for density, mass over volume, if you divide by a bigger number, it gets smaller. And this is why hot air balloons float, because they eventually become less dense than the surrounding air around them. And the last thing I want to talk about with density is water. Water is an important exception to the previous statement I just made. Over certain temperatures, the volume of water actually increases as temperature decreases. Water at 4 degrees Celsius is 1 gram per milliliter, but water at 0 degrees Celsius is 0.917 grams per milliliter. And this is why your ice cubes float on top of your drink, because ice cubes, frozen water, are at 0 degrees Celsius, which is the least dense or less dense than the water that you're actually drinking. Let's sum things up. Density is the ratio of mass to volume. You can arrange the density formula to solve for volume or mass by using the magic triangle. And density can sometimes change with temperature due to a change in volume. Density is an intensive property of matter, and it can be used to identify an unknown substance, which is something that's done in the laboratory portion of this course. That's it for density, and I hope it makes sense. And if you have any questions, please let me know.